All right, Lady Ada, what is this?
Hey, everybody, and welcome to Show and Tell. It's me, Lady Ada. With me is Mr. Lady Ada. We're here at the Adafruit factory, not a green screen. This is the factory where we do all of our manufacturing and kitting and assembly and coding and stuff. Nobody else is here. It's just us in the factory, so we're maskless because we're vaccinated. We live together. But you're bored of us. What you want to see is everybody from the community coming by and showing off what they're working on. So we're going to kick it off with Kevin from Digi-Key. What are you up to, Kevin?
What's going on?
Hey guys, how you doing? How's everybody?
Good.
Good. So just a quick thing that I've been working on. I've been doing a lot more 3D printing lately, and I've learned a thing or 10 from Noe and Pedro. They seem to know everything, which is great. So make sure and watch their 3D Hangouts. But I did start using octoprint this week, or not this week, like last week, and started playing around with it. And this week I added the Adafruit neopixel strip to it, which is a deal breaker because I kept shutting the light off in my office when I would leave, and I'm trying to do time lapse videos, and it would go dark. So the time lapse didn't turn out very well. So anyway, being able to use octoprint and directly integrate it with the Adafruit neopixel strip has been really great. It's been a lot of fun to get it to work with the Raspberry Pi, and very interesting, and I've really enjoyed it.
All right.
It must be fun. Wait, sorry. It must be fun that you can just like go to the Digi-Key factory and just pick up neopixels, whatever you want.
Oh yeah, it's Digi-Key factory's right across town, and it's like a candy store for me. So yeah, I love it. It's been great.
Do that with Adafruit stuff.
Next thing I'm going to do is I'm going to try and figure out with one of the many thousands of Adafruit boards and integrate a sensor to it so it'll sense the light. When I turn the light off, it'll automatically turn white LEDs on.
That's a good idea.
That's right.
We just got we have one of the new iOS devices that has a LiDAR on it, and so I haven't seen a lot of examples yet, but we're going to figure out like how can you scan something in real life, get the file out. There's apps that do that, and then print it. So.
Oh, that's really cool.
Yeah, we'll try to do that. We'll let you know how it works out. It'll be on the show and tell.
Sounds good.
All right. Thank you, Kevin.
Thanks so much, Kevin.
All right, thanks, guys. Take care.
All right, enjoy. Next up, it's Scott.
We're going to go to Scott.
And Scott's map.
Hello. So unrelated to CircuitPython, I don't know if I showed this or not, but this is fiberdeserts.net. It's a project I've been working on in my evenings for, a few weeks now. And the idea is that it should help find areas in the US where people don't have fiber internet. They have cable, or they even have DSL. So this is kind of the current version of it. And the red areas are the places that people don't have fiber, and the more red it is with density. So this is kind of what I was playing around with. But it doesn't have, it just has Washington here is what I did. And I had to switch tech. So I've got this new demo. This is New York. And I don't have the broadband data here yet, but you can see that I'm able to do the same, like hover over all of the regions.
That's so nice.
And it changes the regions depending on your zoom level. So it'll do counties, and then as you zoom closer, you'll do like census tracts and then census blocks. And census blocks are the units that the FCC reports all this stuff in. That's kind of why it's centered like that. And I just wanted to do a shout out because the project that I'm switching to for this is actually a thing called Dataset. Spelled like cassette, so DATASETTE. It's a Python project, and it blurs the line between like static hosting and databases, where you ship a SQLite database with your code, and you can have like as many copies of that as you want. And it has these cool properties that it has this default interface where you can actually just do SQL from the databases that are running on your server. So it's a really neat project. I wanted to show it off for folks, and I'm adding some extensions that handle all of this like GISC data to it. So next step is to figure out how to get the side panel so you can see all the data about a particular block, and then also like joining it in and styling it so you can find the areas that are most interesting.
All right. Well, just like the last round of municipal projects, keep coming back and showing some of the progress, and then you're going to be doing your deep dive CircuitPython stuff this Friday as well. Yeah,
I've been making lots of progress on the workflow stuff. It's not quite showable, but I'll definitely show it next week, hopefully fully functioning, even if it's just a little duct taped.
I love the metro data analysis. I love it when people are like, I want this data. And like, if you think about it, 20 years ago, there was no way to get any information like this about your city, state, country. Now it's like, it's cool. It's like getting GIS data, getting these agencies to publish the data in a way that people can use it. They know that if they just give you the data, somebody else is going to make the app.
Right. And for like the broadband stuff, like there's been a couple of rounds already of like rural funds, and they've not been spent that well, in my opinion, because they're spent usually on DSL. And like people are getting DSL in 2020, which is just absurd to me. So that's one of the things I want to highlight here is like, oh, you're in this area and so got paid $2,500 a household or a person to run you 10 megabits down and 1 up DSL. Like
that you're sharing with like everybody else on your block.
Right. Like, so like instead, I think my opinion is that we should just pay for fiber to folks because that's a better long-term investment. And that's why it's fiber deserts, not broadband.
Okay.
That makes sense.
Fibrous.
All right, there's some dataset and SQLite fans in the chat, so drop some links in there, and then
we'll do.
Catch up with you on Friday, right?
Oh yeah, and then the 2 weeks after that, I will not be streaming because I'm going on vacation. So just a heads up for folks.
Yay! All right.
Thank you so much, Scott.
Thank you.
Next up, let's go to Noe and Pedro. Noe and Pedro, what you got going on this week?
Hey, folks. Hey. Yeah, so we wanted to show a prototype of something that Dylan came up with. So she had this cool Jeopardy game, Brennan the CPB, because LeVar, many remember from reading Rainbow, is going to be hosting July 26th through, what does the internet say, 26th to 30th. So we wanted to make sure we were up, ready for that. So there's a controller here that you push to get the, I guess, the players ready. There'll be 3 of these that can play along. So you do whatever question. We'll just watch it during the show. We'll do a little shout out that we do, and then, you get the answer, and the little the STEM speaker handles some sound effect, and then you can reset that like that, and then have the next player hear the next question go up. So a bunch of wires, but it's all going to fit within this little 3D printed box. We have the CPB inside here, and then the STEM speaker will go on the bottom, and then this guy just snap fits on top with the diffusion, the color, like whatever player, it will have different colors on there that will show up on there. And that is what we're prototyping. And then I wanted to show off some keycap stuff since the main focus of all the projects coming out.
Yeah, real quick, just wanted to share. I milled some of these keycaps. This was a 3D printed lemon pad from a couple weeks ago. So just wanted to print some of these keycaps. Mill some of these keycaps in this hard wood. So we got a couple of these really nice keycaps in the shop. So I've been using this as like a reference point to see like how can I mill the stem, because that's really the most important piece about it. Hard to focus, but whatever, what you gonna do. So I did do that, and I ran through some failures here. So this design didn't end up working too well, so I kind of reworked it so it's more of an enclosed bit here. So you kind of see that. I'm sorry about the focus, but what are you gonna do? Yeah, so it ended up working out pretty well. I also want to do some like multi-material. Maybe I can mill this out of some HDPE or some aluminum and kind of press fit in there. But so far it seems to be working pretty good. And then we have some other kind of different shape ideas, because like the whole point was to kind of make something that wasn't a square. So CNC milling, learning some different things.
Okay.
Very cool. And folks, tune into your show every Wednesday.
Yes.
Yeah.
So,
right.
Videos and more.
This couple has the longest running 3D printing show on the internet. Phil, you got it.
I'll take 3D Hangouts for 300.
Thanks, folks.
All right.
Okay. Let's go to John Park. John Park, what you got going on?
Hey, hello. So I also have I got some Bongo Cat going on here. I showed this yesterday, and you might be showing a clip later, I don't know. But the thing I'm showing on here is actually this feather wing, which is a 2-key switch feather wing. And one of the things I wanted to point out is that since I was using this yesterday and I was actually knocking keys off when I was using it, I 3D printed a little switch plate, and essentially the switches click into this, and they give each other a little bit of stability. Usually keyboards have these a metal stamped plate or something like that. So I've added that here, and then I've also been working on a fun little remake of a popular project in the mechanical keyboard community that's called the 2% Milk, and it's a 2-key macro pad, and it's in a milk carton. So I designed my own version of that model that fits a feather and our feather wing. So this one I've got our NR52840 in there, a little space for USB, a little space for reset, and then a couple of keys. And you can see there again, I've got a key plate holding those switches in nicely, so they'll be nice and stable, nice and solid as you're using them. They won't wiggle out because these are socketed. So these switches are sitting in a little socket. They're not soldered in. And then the third thing of my keyboard stuff going on today is I showed this really huge novelty keycap and key, and I've modeled and printed a little stand for it here so we can still sort of see its innards. And I just got in today some of our 8mm diffused neopixels, and I hooked that up to it. So now I can do some lighting effects when you press it. This one's not doing anything right now. It's not going to like shut off my computer, which is good. I've disabled the USB output, but normally we can use this to output USB. And now I can also do some cool lighting effects with that big juicy neopixel. All right, that's what I got going on.
It's so chunky.
We'll be playing some of your videos tonight on Ask an Engineer, and then tomorrow is JP's workshop and more.
Yeah, come on by for more fun.
Okay.
Clicky, click, click.
Jump,
Click,
jump.
click, click.
Next up, let's go to Paint Your Dragon.
Oh, hello there.
The eyes have it.
The eyes have spoken.
I thought my eye days were behind me, like we were done with eyes. But actually, on the weekend, I had some questions from someone who actually makes monster stuff. And they wanted to use the monster mask in a project of theirs. And this board, it's wonderful. It's so slim, but even then, this the Elton John frames around the eyes were problematic for them. It was still too chunky for what they were doing. And so I think Lamore showed these on It's Not Out Yet one time, but we were both looking at these round TFT displays.
Wow.
And anyway, I got the eyeball code working on a itsy bitsy M4. It took surprisingly little work. And these displays, because they don't have the big frame around them, hopefully that will fit inside their monster application better. So that was just a weekend project that I did, and I thought I'd show it.
They're cute. Wow.
Yeah, they are cute, aren't they?
All right, very cool.
Hi. Hey, guys.
All right, thank you so much, Libby.
You bet.
All right, next up, we're going to go to Brent. Brent, what you got going on?
Hello. This past week, I've been working on Adafruit Wippersnapper, and we're getting close to finishing it towards a beta, which is really exciting. And one of the difficulties is how we're getting it to people. And with Adafruit IO Arduino, we distributed it. We had this configuration file, and if you're using a airlift on your board, you would uncomment a line. You would comment a line if you're using Phono or Ethernet. And with CircuitPython and all the work done in CircuitPython, I thought that we could make it a little bit easier. So I have a board over here, and it's a Metro M4 airlift. And if I connect it, you'll see a Whipper volume mount, just like the CircuitPython volume.
Ooh.
And that volume contains a secrets.json, and I'm not clicking it because it has my keys on it. But what it looks like, I have a templated version. And if it doesn't exist, they'll make it already, is you can store your IO username and your IO key. And in addition to that, you can store what type of network interface you're using. So if you have an ESP32S2 with native Wi-Fi built in, all you need is your SSID and password, right? But if you have a Phono, you need your GSM ID, in addition to a lot of other different properties that aren't available through this native Wi-Fi interface. So it'll let us add different interfaces for different board types. And that's what I've been working on.
Neat.
All right, very cool. You're making IoT too easy. We'll get that feedback later, so we'll deal with it.
All right. I love Tina USB making mass storage a thing. It's now a thing.
All right.
Thank you, Brent.
Next up, we're going to go to Shawn.
Oh, hey,
Hello,
Shawn.
Shawn. How you doing
Okay,
this week?
got the double Digi-Key. What's going on, Shawn?
Yeah. Oh, you're on mute, but you're going to
I will unmute. There we go. I got it. I'm actually not repping Digi-Key. This is my own project I said I would get working last time, and I got it working. And I know I've shown this off before on a previous show and tell.
You got a great setup here.
Thanks. Yeah, I've got my ultra wide and then my secondary.
Yeah, more.
I know, just I need one on this side with the vertical so I can do more code, right?
Yeah.
And so what I've got here is the Feather STM F405, and I was doing TensorFlow Lite for micros on it by hand by converting stuff to a basically a spectrogram, and then using a convolutional neural network to look for spoken words from it. However, I've updated it to Edge Impulse, where I've just uploaded all of my samples and used their stuff, which computes the mel frequency spectral coefficients, which are slower, but they did all sorts of optimizations. So now it runs happily in an STM32F405, and it works way better. So
okay, do it.
Here we go. So I've got still full control.
Yeah.
Hadouken.
Oh,
you can't. Hadouken. Oh, it's not listening to me. Here we go. Hadouken. There we go.
yeah.
Let's see if I remember the actual combo, right?
All right, sweet.
All right, good work.
Thanks.
So that was
That's cool. Custom voice commands are really, really, really hard to do.
And it's not internet connected, and it's an edge device. You know, that's one of the things that we always try to explain to folks why we're interested in this collectively as people who do electronics, because you don't have to have a giant cloud computer with an always-on microphone in your house. You trained all the models, and now it lives on that. So
exactly, all the voice stuff's being run right here on this little microcontroller. That's it.
All right, good work.
Yay!
Thank you. Thanks for having me.
Okay.
Hadouken.
I just yell that constantly now.
Yeah.
All right, good work, Shawn.
All right, thank you so much.
You are the Street Fighter. Okay, next up,
we're gonna go to Bill.
Hey, Bill.
Hey guys, how are you?
Hey.
All right, Bill, what you got going on this week?
I got weird stuff this week. So what I've spent most of the week on has been working with Dan Halbert to get the custom descriptors working, and they work. So you can go into boot.py. In this case, I took a known good Xbox adaptive controller gamepad. I was able to manually enable it, and it totally worked, and the Xbox doesn't freak out, and I'm not having to use a custom build of Circuit Python. So that's awesome. He then made a mistake and asked me what would be next, and I told him this eye gaze bar, and it has multiple reports within one descriptor, which is going to blow apart his stuff. So now we're working on that. So that's what we're working on.
How's the customizable USB so far, though? Have you been able to do the XAC stuff, or is that still?
Yeah, the XAC stuff's great. In fact, it's very simple. You put in figuring out the descriptor sucks, but that's not your problem.
Yeah.
Once you know the descriptor, loading it in is easy. We are going to change this in that I'm going to need to give him, if there are multiple report IDs, I need to tell them what they are. So he's going to add that in. That's going to require a little change before 7.0 comes out. But with that, that's only for the next step. For the current thing of I need a gamepad that is weird because Xbox adaptive controller is weird, it works perfectly. And it's easy. It's super easy. You put it in boot.py. You have to remember to do a hard reset every once in a while. And that's it. It just works.
I saw how accessibility technology, it's like, it used to just be like, okay, how can we work with people and make, diagrams and cards. And now it's like, okay, you have to know HID, 3D printing, multiple operating systems, boot style, keyboard configure. It's just so intense. It's cool because we actually can make this stuff. It's fascinating.
Is really cool what we can do with Python. So I was never a Python guy before I started working with you guys. But what you can do with Python in 50 lines of Python, you can do ridiculous things right now. The thing that I wanted to show you is something that I was asked for. Let me change what I'm looking at here. So this is what I want to show you. And I don't think I've ever shown it here before, but I should have because it's been over a year. So this is actually, I'm going to go back to my camera for a second here. So this is actually what I'm going to be making a bunch of. I got a request from a large company that won't be named that they're doing an outreach event, and they wanted something where they could teach people how to solder. And they said, do you have any kits or anything that would be useful afterwards? And they happen to have a lot of Xbox adaptive controllers in their company. And so this is something we designed a while ago that takes in this joystick, which is one of the, so I took your design, Lamore.
Yeah.
I added two jacks to it so that you don't have to do any wiring, because before that it looked like this with glue and little tiny wires. So I made this design a while ago, but it really it was really kind of brutal to manufacture. So I wanted to show this to Noe and Pedro. I went into Fusion and I made a negative of the board. So that you can literally just pop this thing on and you've got a jig for doing all your soldering. Isn't that great?
That's a great idea.
All I did in Fusion was literally go in and extrude down the parts. Just I can show you over here.
You know, making jigs is usually the hardest part of manufacturing, but you are like 3D.
Yeah. So if you want to show my screen for a second, I can show you guys this. So what I did was I took the part, because when we make parts, and I'm pretty sure the Reese brothers do the same thing, they lay out their parts, right? Because you can download all these parts. You lay them out and then you build your case around it, right? So you build the top around it and you build the bottom around it. And what I did was I just flipped it over. I turned off the knob, flipped it over and projected parts into a jig, right? So if you look at the sketches, and turn the sketches on here, right? I projected in the parts and then I just added some space around them and pushed them down. And it was super easy to make a jig that would hold that. It took a couple of test prints, but now I can give them the board, the joystick, the 2 switches, and one jig per table. And they can crank these things out as just a way to practice soldering. And I love this idea of making the jig with a 3D printer.
This is so cool. All right. Yeah, you should work with the Noe and Pedro, maybe publish this up or
Yeah, we can make a guide on it. Absolutely.
Okay, sweet. All right, we got a lot of other people, so we got to go. But this is good stuff.
Thank you so much. Bill. Good to see you. All right, for everyone else, if you can keep it to like a minute and a half, we have a full house tonight. We'll be able to get to everyone. Yeah, more people showed up even. Okay. So let's go to Eddie next.
Hey, Eddie.
Hey.
Hello. What you got going on? Yeah.
Oh, cool. So I shared this on the channel the other day, but I'm building. This is for the Omega Zero that I've been promoting.
Yeah.
The owner of it.
Congrats on your efforts. We've been retweeting and been watching all the progress. Good work.
Thank you so much. So this is running CircuitPython, and this is to automate my garage. But what's new here that I didn't share last time is now I added the Raspberry Pi Zero here. And before, this was sending all the information to the MQTT server on Adafruit, so Adafruit.io. And I can actually share. Can I share my screen so you guys can see the back of it?
Right. Just keep it to a little bit under a minute so we get to everybody else, and I'll as soon as I see it come up here, I'll add it to the.
There you go. So this is where the data was going before to the Adafruit. Can you see the?
No, your screen didn't come up.
Oh. Okay, I guess it's not going to allow me to do it.
You have to get permissions and stuff.
Yeah, so anyway, so this is sending the data. I have sensors that measure temperature, humidity, and a bunch of stuff on my garage. So this is all sending it through this stack. And then from the Adafruit IO backend, I can trigger to open and close my garage. But also I can monitor the temperature and all that information from the dashboard. Now, the reason I changed it now and added a Raspberry Pi Zero in between is because I wanted to have real-time information. So I made a mobile app. So I can also see everything in real time, which I was able to do it through the backend on Adafruit IO, but I wanted a little bit more control because I want to add different devices that tells me home when the doors stay open. Like, so I have left my garage open overnight a few times, so I'm preventing that. So this thing automatically detects if it's open, and it will automatically close the garage.
Hey, it worked.
Yeah.
All right, great.
Yes. So I don't want to get out of time, but thank you so much. I just wanted to share this project.
Yes.
Really
and please feel free to drop links on where people can find out more as well.
Thank you. I will do.
Thank you, Eddie.
All right.
Thank you so much. Bye.
I'm gonna call these out in order so everyone can get on deck. We're gonna go to Tavis, and then Mike, then Stuart, then Mark. So we got a lot of folks at Tavis.
Hey, Tavis.
Hey.
So this project.
So I've been messing around with Nixie tubes lately. So the first thing I did was these little dice that you roll, you shake it.
Oh, this is so dangerous.
See, each one's a die.
Yeah.
And then it adds the two up and gives you the result. So after I did this, I made this little board so I could not have to hand wire everything. And then built this guy. So my pops did the artwork.
Oh, nice.
Cool.
And he's got 2 Russian Nixie tubes in the top.
Wow.
And you guys' LED display for the eyes. And your soundboard is making the sounds.
Oh, this is great.
This is great. I'm creeped out, but also intrigued.
So the top ones are some kind of Nixie tubes used for probably some kind of measuring device, I would guess.
Probably measuring other Nixie tubes.
Yeah,
That was awesome. All right,
he's got a
beautiful.
glass front on him, so it's reflecting.
Yeah, no, we can
We can
see
see
it. If and when you get around to taking some photos of it, can you send me an email, PT@Adafruit, so I can post these up on our blog?
Yeah, and I was gonna make a little YouTube video too.
Oh, yeah.
On my channel.
Send all that over, and we'll do a blog post. That looks beautiful.
Awesome. Okay.
Nicely done.
All right, thanks,
Thanks.
Smith.
Take it
All
easy.
right. Next up, we're gonna go to Mike. Hello.
Hey, Mike.
Hey, how you doing? Long time.
What's going on?
Let me go and share my screen here.
And then after Mike, we'll go to Stuart, then Mark, and we should get just in time if everyone keeps it to like a minute-ish.
All right. After this sitting around for multiple months after the Ada box came, new one came, how to use it. So this is cycle 25 for all the ham radio guys and people wondering about that. Sun runs an 11-year cycle, so it goes from bad to really great, then it starts sliding down and starts over again. So this shows the info, and depending on those numbers, I say get on the radio or get back to work.
Cool.
So
How
from
far
an
can you-
example
how far
point
can you
of
get?
view, I've done a couple of cool things because I didn't see it. I have both it sleeps for 4 hours at a time, but if you press one of the buttons, it will wake up on that. So I have both types of alarms working on here. And I didn't see any example code that clearly showed how to do that. Also, what I have is a battery alert. So if the battery voltage gets below 3.3, I wake up, I say battery low, beep 10 times, and I wake up every 2 hours until you plug it into the USB-C port. For the events, there are all the solar events. And if you press it, you know how this thing works. It takes a while to update. It will show, right now it's really rough. But as soon as this thing decides to update, there we go. It's just printing the raw first entry of the JSON file that's published by Noah.
Cool.
So I need to get that published. And then it should flash once more, so you can go back to refresh or events. So
What a
I
good
don't
radio
know
friend.
if you've got examples that are using both time alarm, and button alarm. If not, maybe I can polish up, do something, and publish this on the Learn site.
Publish it. Yeah, we've got a lot of ham radio people who'd love to try it out.
Well, I've got, let's see, send. Of course, it's on GitHub. There's the link.
Okay, cool.
Thank you so much.
Thank you,
Yeah.
Mike.
Good seeing you guys.
Good to see you again. Yeah.
All right, 73.
All right. We're going to go to
Next up,
Stuart,
Stuart.
and then Mark back to back. Take it away, Stuart.
Can you hear me?
Yep.
Yeah, he's right.
Okay. Yeah, so I was getting ready for my vaccine, I guess, sometime this month. So I decided to make what everybody else was making.
Cool.
This is a remix from Noe and his brother.
This is great.
So what I did was, that's the QTPy2040.
Yeah.
And the OLED, and use some laser CNC here and here for that. And for the back, I'm covering all the wires. What I did was I got the back STL converted to SVG and did a cutout from the pre-cut from a light stock paper so it can cover the wires and things like that. But once you turn it on, it does vaccine. I don't know if you can see it. And it says vaccine.
This is great.
And it blinks the neopixels. So,
All right.
I love
this. Stuart.
I love this project because when people imagine like vaccine passports in their head, they're like, it's going to be like this, and you built it. So good work.
Nice work.
All right, Stuart. Well, thank you so much.
Super cyberpunk.
All right, Mark, play us out.
All right, Mark and Mark's
Yeah.
barbecue.
You can show my screen.
Yeah.
So this was an old lantern that I grabbed at a friend's when we were having a campfire one day. It was one of those free days when there was stuff on the street. And this was probably 10 years ago. So I have since been working on it. And I can stop sharing this and show the brand new one, which has now been restored and painted. The next step is to try to find plastic to replace the plastic on the inside. So if anyone knows flexible plastic I can get in here, please let me know. And then, of course, to put LEDs in it, because why else would you build something?
It almost looks like
you got good reasons.
In New York, there's these like stained glass water towers. They were art projects essentially, It reminds me of that because it looks like a mini water tower. But the flexible film,
PETG or something.
The flexible film that you use for lights might work.
Yeah, it's PETG.
Yeah, PETG is what you might want to look at.
It's very flexible.
I've learned a lot about plastics in the last 2 days.
Yeah, just go to the plastic shop. They'll have sheets of it. It scratches easily, but it's super cheap.
Yeah.
Works great.
All right.
Thanks a lot.
You, Mark.
Well, very cool, Mark. Thank you so much for coming by and sharing your very good find.
Okay, thanks a lot.
I love recycling.
All right.
Upcycling.
That's it. Full house tonight. Thank you so much, everybody. This is our favorite half an hour every week. Show and Tell. We're here 7:30 p.m. Eastern time every Wednesday. Next up, Ask an Engineer starts in a matter of seconds.
Yes.
Bye, everybody.
See you on the other side.